Okay, hello everyone, it's Salar, uh, and we are in part 49 of our tutorial, a tutorial writing a real-time operating system. In previous part, I described kernel space system called function. This function, for example, as an example. Okay, as an instance, I inspect thread create new system call, a kernel space system called functions. And now you completely comprehend the structure of system call in the RTOS. And the last stage was kernel space system call. But in this part, I want to talk about RTOS Initialize, RTOS Start, and context switch. Okay? Some simple topics. You can see before calling system calls, you must initialize the thread by using up this function RTOS Initialize, and this function by itself called kernel initialize. Okay, now I want to inspect this function. Okay, but what does RTOS Initialize do? Just initialize kernel control block. Just initialize this struct kernel control block. Initialize version state tick, find current running thread ID, initialize system call list, ready list, and initialize this to variable to onset. Okay, so as you can see, first allocate memory for kernel control block. After that, initialize kernel version. Okay, read this part by yourself. This is easy. Initialize some numbers. After that, set state of kernel at this time to kernel state initialized. Okay, it's not a start or a stop. After that, set tick number to 0. Set tick to 0. Here. After that, first set current running thread ID to null. We initialize this thread to a thread ID at RTOS start. Okay, another time RTOS start initialize current running thread ID to a thread ID, and unset the value of system call, handler request, and context switch request. Unset these two values. Okay, and do some works in port device initialize. For example, set pendsv and svc priorities. I said priority, you must set the priority of pendsv to 14 number of priorities -2, and svc to 15 number of priority -1. Okay, so this is RTOS initialize responsibilities. Okay, kernel control block initialization, and set the priority of these two exceptions. Okay, but what does RTOS start do? To start the kernel, you must call this function, and this function by itself called kernel start. And what does kernel start do? First, find most prior thread in ready list. Okay, by this part of code. By this part of code, find most prior thread. Okay, for example, assume in thread high priority you have thread 1 and thread 2. In normal you have thread 3, thread 4, and for example in the low you have thread 5 and thread 6. At this time, in this list, in this circular queue, okay, priority of high, thread 1 is first thread in this list, in this circular queue, and is most prior thread. This code, for example, find the thread. First, find the most highest priority. For example, number of priority is 8 and the highest priority number is 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7, and start from this priority. Check this. First, check highest priority list or circular queue. First, check this circular queue that's related to priority number 7. If list is empty, priority minus minus, now priority equal to 6, and another time go to the startup while. Okay, if a list is empty, check priority number 6. Okay, check real-time priority. Okay, and do these works until find a thread that is not empty. For example, priority high is not empty. Okay, when the priority value is equal, the list is not empty, and list has 2 members, thread 1 and thread 2. Get first thread in priority, for example number 5, thread 1. Okay, now thread 1 is most prior thread and is first thread to run. Okay, and after that push index to thread 2. After context switch, operating system will run thread 2 because we pushed the index by using of this function. So by using of this code, you can find the most prior thread in ready list. Okay, most prior thread, for example, thread 1 at this, in this example. After that, set current running thread to first thread, which find in stage 1, step 1. Okay, find most prior thread, put the address of that thread, ID of thread in first thread ID. After that, change the state of first thread to running, to run the thread. After that, set current running thread by using a first thread. After that, change kernel state to running. As I said in previous parts, RTOS starts change state of kernel to running. After that, tick timer initialize. Tick timer initialize set kernel state. Tick timer initialize. And in tick timer initialize tick timer by using up core frequency and set the priority of tick timer to 0. As I said in previous parts, you must set priority of tick timer to 0. And after that, run this function, start first thread. Start first or most prior thread by using up this function. This is an assembly function, okay? And here is an inline assembly code. To start most prior thread or first thread, first get current running thread stack pointer by using of this function. First find current running thread by using of kernel get current running thread ID, and after that get stack pointer of current running thread, at this time first thread or most prior thread, and do unstacking. Change the stack pointer by using of this instruction, stack pointer plus 64, because as I said in simple RTOS, when you want to unstacking, you must change the value of PSP and write this value to PSP. Write this value to PSP. To comprehend this part, refer to simple RTOS parts. Okay, I've completely described this part in simple RTOS parts. Okay, after that, for first thread get thread function pointer. Okay, get thread function pointer for example to this function. Okay, and put this value in register R4, because return value in register R0 after returning from this function, return value has been returned in register 0. Now write thread function pointer to register 4, address of thread function in register R4. For first thread, get thread function parameter, this value. Okay, and write this value in register R5. Like before to start, the RTOS change privilege of processor to unprivileged and use PSP or process stack pointer as a stack pointer for writing value number 3 in control register. I completely talked about control register in previous parts. After that, write thread function pointer R5, another time in R0. Okay, because when you jump to this function, you need to have this parameter in register R0. According ARM architecture procedure called standard, you have your argument or parameter in register R0 when you are in the function. Okay, and after that write thread function pointer first to register R3, and by using our register R3 thread function pointer and branch and exchange instruction, jump to first thread function pointer, address of first thread function. Okay, but let's do see running of RTOS Initialize and RTOS Start in debug mode. Okay, now first inspection of RTOS Initialize. RTOS Initialize call kernel initialize, and kernel initialize kernel control block. Set version, set state, set tick, set current running thread to null, and unset these two members, set to 0 or unset. Okay, now kernel initialized, state is initialized. Okay, tick is 0, current running thread is null, system call list and ready list initialized, and these two member initialized to 0. Okay, and after that return from function. Before any other functions in the RTOS, you must call RTOS Initialize, and after that create two thread. Now in the ready list you have just two thread in normal list, thread 1 and thread 2, and thread 1 is first thread in this list because added before thread 2, the circular queue. Okay, these two thread inserted to normal list. Now RTOS starts. RTOS start call kernel start, but kernel start first find most prior thread, priority 7, priority ISR or 7. Okay, this list is empty. Because this list is empty, another time do priority minus minus, and another time check priority. Priority 6 or real time is empty. Priority minus minus, no. Priority high is empty. Now priority above normal. Priority above normal is empty too, but at this time priority normal. Priority normal is not empty because it's not empty. Jump to else. Get first ID is 9D8 is 9D8 2000009D8 ID of thread 1. Okay, and push index. After push index, first thread in this circular queue is thread 2. Okay, after push index, and break the while code. Okay, now change the state of first thread to ready, to running. Now state is running because you want to run this thread. After that, set current running thread ID to first thread. In kernel -9 in kernel. Current running thread is 20000098, ID of first thread or most prior thread. After that, change the state of kernel to running, initialize tick timer, and run this function. Okay, and after running this function, let's do a breakpoint here. After running these instructions, RTOS jump to first line of thread function 1, most prior thread. Okay, jump to first line, and in register R0 you have value of 0, null value. Okay, you have the parameter, this parameter in register R0. Okay, here was RTOS Initialize and RTOS Start. But let's talk about context switch. You know, after each 1 millisecond, okay, at this point RTOS do context switch and find next thread and run that. Okay, after systematic interrupt, the RTOS changes running thread to next running thread. Okay, so at tick 0 RTOS run first thread, thread 1, but in tick 1 RTOS run thread 2. But let's do inspect context switch by debugging. As I said, after kernel start, RTOS jump to first thread, thread 1. But after 1 millisecond, you will have a systematic interrupt. After 1 millisecond, RTOS processor jump to systematic handler by a systematic interrupt. If you run, sorry, remove this breakpoint. After 1 millisecond, our processor jump to systematic handler. Okay, like SVC handler, first push link register and another register for a stack 8-byte align. Okay, to preserve a stack 8-byte align. Okay, register R0 and another register. This register is not important like before. After that, increase tick. Okay, you know the value of tick is 0. Okay, the value of tick is 0. But after running this function, kernel increase tick, now the value of tick is 1. Okay, after that, do kernel context switch request, run this function. Let's do inspect this function, jump to this function. First, set context switch request member in kernel control block. Set this value. This value is unset. Okay, set kernel context switch request. Okay, after that, call pre-supervisor interrupt trigger. What's this? Set pendSV. And in pendSV handler, RTOS does context switch. But if you set pendSV handler, because now the processor running system-tick handler and system-tick handler has higher priority, processor doesn't jump to pendSV handler. If you set this value and return to another time system-tick handler and return to thread mode, now processor jump to pendSV handler. Another time if I press step over, run pendSV handler. Like before, push link register in stack. And like system call handler, check for system call request by using this part of code, okay, this part of assembly code. In future parts, you will realize why do we need to use a variable and check that, okay. You can see the value of R0 before calling this function is 0, but if call this function, return value is 1, okay, and a context switch request has been issued, okay. And by using this if then block and branch equal instruction, jump to this part of code. This part of code is like simple RTOS, okay. First do stacking, okay. First write register R4 to R11 to stack of thread 1. I completely described unstacking and stacking in simple RTOS. Refer to those parts. Okay. First, do stacking for thread 1. After that, write value of new PSP in R0 as argument of this function, and change the value of the stack pointer in thread 1 control block. Okay, after that, run kernel context switch, and this function like kernel start find most prior thread, but at this time most prior thread is thread 2 because we have a push index in kernel start. Now first thread in this list is thread 2. Okay, another time run until above normal, until normal. At this time priority is normal, okay, and priority normal list is not empty, so processor run else block, find first thread in normal ready list. At this time here is next thread running, ID of thread 2, okay, B38, thread 2 is B38, next thread to run, okay. Another time push index, another time push index to thread 1, okay, and in next context switch RTOS run thread 1. Break while. After that, change the state of thread 1, okay, state of thread 1 to ready. Now thread 1, okay, thread 1 state is ready. Change the state of next running thread, thread 2, to running now. State of thread 2, you can see thread 2 is running to run the thread, and after that change current running thread. Okay, you can see at this time current running thread is 98 ID of thread 1. Okay, 98 ID of thread 1. But by running this function, now current running thread change to B38 ID of thread 2. Okay, and now context switch has been done and current running thread changed to thread 2. Now do unstacking for thread 2. First get a stack pointer of thread 2, write value of stack pointer of current running thread stack pointer, thread 2 stack pointer in register R3, and do unstacking. Write the value of R4 to R11 from stack to the registers. Okay, load to registers, and write value of register R3 to PSP, process stack pointer, unset context switch request, unset this member. Okay, this member is set. Unset this member because context switch has been done. And return from pendesv handler. Return to, if I put a breakpoint here, return to thread function 2. Okay, at the for first running, start running from first line of this function. Okay, so this was the process of context switch. Now I described RTOS Initialize, RTOS Start, and context switch. And enough for this part. Thank you very much to see me, and see you soon in the next part. Thank you very much.